So you want to know about hot ice? Something we believe lurks deep in the cores of ice giants like Neptune and Uranus. I defy you not to be titillated by the forthcoming conversation about physics and chemistry. Now, hot ice is not the technical name. I'm just calling it that because it's hot and it's ice. If you wanted to describe ice, you would actually describe it by its phase, the way that the H2O molecules behave under given pressure and temperature conditions. You already understand some of the phases of water that we deal with. Of course, there is a liquid. All you have to do is add a little temperature. Bam, you get a gas. You can reduce that temperature, condense things, go back. And if you remove some of that energy, if you make it colder again, you can rob those molecules of that kinetic energy and they kind of lock in place. You get a solid. And this solid ice, the type you put into your drink, is actually called ice 1H. It's the first phase of solid ice. Those are the basics, but now let's get to the exotics. This plot has temperature on the x-axis, so as we go to the right, the temperature increases, and as we go up, the pressure increases. On the surface of Earth, we have about 1 bar. This is an Earth atmosphere of pressure. And you see that at 100 degrees Celsius, water boils. You know this. And at 0 degrees Celsius, water freezes. It transitions to ice 1H. That's at 1 Earth atmosphere. What if you shoot this pressure up? What if we move up to 1 million times Earth's atmosphere? 1 megabar. Liquid water can't exist. The oxygen molecules, which are big, can't move around because there's too much pressure, forcing them to be sluggish, to be stuck. And when molecules stop moving, they become a solid. And this solid is hot. This ice has a high temperature. Here's a similar plot with Neptune and Uranus plotted on. At 100 gigapascals, this is 1 million times the pressure on the surface of the Earth, and thousands of Kelvin, you can reach ice phase 18. This ice 18 phase, called super ionic ice, has the oxygen packed so tight that it can't move at all. It's locked into a lattice, and only the hydrogen molecules can move freely. So you end up having this immense pressure, this very rigid, solid object, but with hydrogen, basically just free protons moving through it fluently. You end up with ice that is thousands of degrees Celsius. This is what we think is at the center of planets that have significant water mass fractions.